Okay, folks, here we are going to check part 1 of the Chapter 10 review assignment. As you hopefully saw in the email I just sent, I have found it very difficult to keep up with the videos. This video I had intended to post before 3, and now it's 4:30, and anyway. The test that I had planned for Thursday for you guys will be postponed until Friday, and we'll see if I'm able to keep up with that schedule. Got to rethink the way I'm doing some things. And you know something? I snagged the cord when I walked over here. I'll bet the camera's not pointed in the right direction. Let's fix that. Okay. Try again. Sorry to be wasting your time with this at the moment. Okay, why can't I get this thing to shrink down any farther? That's weird. Okay, that's going to have to do for now. Okay, good enough. All right, hey, special request, because I've been getting about 80, 85 emails a day for homework assignments from various classes. Please, I beg you, everybody, when you send me an assignment, in the subject line, put physics, and then tell me the chapter number and what part of the review it is. In the future, there may be other assignments other than just review assignments, I don't know. But at least for now, for the new assignment that will be due on Thursday, not Wednesday, because I'm getting this to you late. The part 2 that will be due on Thursday, please make this your subject line, physics, chapter 10, part 2. Anything else I need to tell you about? A repeat. I believe I listed this before in the previous video, but the part 2 assignment is as you see here. I think you've already seen that before. I'm not going to dwell on that for a long time. You can always pause it if you need to see that in more detail. Okay. Now moving on. By the way, I understand that there have been some folks in my classroom fiddling around with chickens. Well, please, I don't have to ask you to not fiddle with chickens at home, I suppose, but what was that? That's weird. Anyway, I don't have to worry about chickens when we're doing the online videos. That should not be an issue anymore, so it's a good thing. Just keep your chickens to yourselves, and we will now move on and start checking Chapter 10, Part 1. Number 1. We've got a heavy crate. It accidentally falls from a high-flying airplane just as it flies directly above a shiny red Camaro smartly parked in the car lot. Relative to the Camaro, where will the crate crash? All right, so the idea is very simply this. The crate is on the plane. It already has its forward velocity. Ignoring air friction for a moment, that's not going to change. As soon as the crate is released, as soon as it falls from the plane, gravity takes over. Gravity accelerates it downward, but it still has its horizontal velocity. Now, even considering air friction, it still has horizontal velocity, although the horizontal will be slowing down, but it still has horizontal velocity. Therefore, if you drop it here, will it land directly below? No, you drop it here, it's going to land over there someplace. If I could get a zoom out farther on the video, I would demonstrate, but use some imagination. If I drop the bag here as I walk across the room, it's not going to fall where I was, it's going to fall in front of where I am. With the car parked back here, it'll fall in front of the car. Okay, clear enough? I think so. Number 3, how does the vertical component of a projectile's motion compare with the motion of vertical free fall? In a projectile doing that, how does its vertical motion compare with the vertical motion of an object simply being dropped? Well, we've been through that before. You saw the demonstration with that little apparatus that dropped a ball and shot a ball at the same time. What was true of the vertical components? They were the same. Horizontals are very different. This one has no horizontal. This one has horizontal. But the vertical components are the same. They will both hit the floor at the same time. Number 4. In the absence of air drag, why does a horizontal component of a horizontal's motion not, let's try that again. Why does the horizontal component of a projectile's motion not change, while the vertical does? Well, because gravity is in the vertical direction. Vertical force of gravity can affect vertical motion, but a vertical force cannot affect horizontal motion. Gravity is perpendicular to the horizontal component. So it doesn't change, gravity cannot change the horizontal vector. But it does change the vertical vector. It obviously accelerates downward at about 9.8 meters per second squared. And we move on to number 6. Let's see. Will a bullet drop the same vertical distance in equal times as an object simply dropped? Yes. Again, as discussed in class, if I fire a bullet horizontally, bam, and at the same time that bullet leaves the barrel, I drop a bullet over here, bam. The two bullets will hit the ground at the same time. Hard to believe, but true. They will have the same acceleration rate downward. The moment that bullet leaves the barrel, it begins to accelerate at the same rate as this one that was simply dropped. They have the same vertical acceleration rate. They will hit the ground at the same time. So if the ground is here and the gun is, pretend, that's terrible. If the gun is here and I drop one object here and the other one is shot here, the vertical component of that motion is going to be kind of like this. Am I coordinated enough to do this? I don't know. It'll be kind of like this. They will hit the ground at the same time. All right, moving on. Number 8. Two golfers hit a ball at the same speed, but one at 60 degrees for the horizontal, the other 30. Ignoring air friction, which one will go the farthest? Well, you know the rule on that. If I shoot one at 60 and another one at 30, they will go the same distance. Bam. Complementary angles. 60 plus 30 is 90. These two angles will have the same range. 70 plus 20. 90, a 70-degree angle and a 20-degree angle will land at the same place, ignoring air friction. Therefore, the greatest possible distance would be 45 degrees. Launch it at 45 or at 45, and that's the farthest it can go. Yeah, I'm saying too much. Need to try to fix that. There we go again. Let's see. Number... Oh, which hits the ground first, by the way? Yes, this one will hit the ground first because it simply doesn't have to rise as far before coming back down. So this one will hit the ground first. Also keep in mind, it'll hit the ground first because it has a larger horizontal component of its velocity. This one has a smaller vertical component. If we were to look at those, this one has a relatively small vertical component right there, whereas the other one, this one has a larger vertical component right there. And pardon me if I'm trying to rush through these, but I have learned from my experience early on that if I spend too much time on these things, it gets too long and takes too long for me to get the videos produced. Number 9. When a rifle is being fired at a distant target, why isn't the barrel lined up so that it points exactly at the target? Well, because when the bullet leaves the barrel, it's going to start to fall. Yes, it's the monkey gun thing. If you've got the gun here pointing at the monkey in the tree here, there's my monkey in a tree, a very weird looking tree. That's not a tree, that's a T. Anyway, we got a monkey in the tree. If you aim the barrel directly at the monkey, if he falls, so will your bullet. It's going to fall. If you aim it directly at the monkey, it's not going to hit it. You have to, in fact, more specifically to this question, if you've got a target you're shooting at here, and you've got your gun over here, you have to shoot the gun a little bit high so that the bullet will fall and hit your target. Especially notable with paint guns or airsoft guns where you can see that arc. Moving on to number 10. We've discussed this in class at length. I don't know that we need to say much about it. Will the monkey be hit anyway? Yes, he will, because as the dart falls from the vertical path, so does the monkey fall, and they fall together side by side. They will hit the same point. Does it matter how fast you shoot the dart? No, it doesn't. It'll hit anyway. We discussed that at great length in class. I could pull up the old slides I have for that, but I'm not going to bother. You remember them all. Number 12. When you jump upward, your hang time is the time your feet are off the ground. Does hang time depend on your vertical component of velocity when you jump, your horizontal component, or both? Well, as you jump, the horizontal speed has nothing to do with the vertical. The amount of time that you're going to be in the air depends on your vertical component, because it's the vertical that determines how long you're going to be up. Now, I am told that for long jumpers, it's a whole lot easier to get a greater hang time if you are running than if you're standing still. That I believe is probably true, but that has to do with human physiology. The physics says that what determines how high you're going to jump is your vertical component, not the horizontal. Moving on, number 14. Assuming no air resistance, why does an 8 kilometer per second horizontally fired projectile not strike the Earth's surface? Because if it's moving 8,000 meters per second, if it's moving at 8,000 meters in 1 second, how far will it fall in 1 second? As with anything else, it'll fall 5 meters. Of course, this is not to scale. It'll fall 5 meters in that same 1 second. It's traveling 8,000 meters per second. It also falls 5 meters in that same 1 second. Well, the cool thing is that that happens to match the shape of the Earth, which also drops 5 meters for every 8,000 meters. That being the case, as that thing falls, it will keep missing the Earth and be in what we call orbit. That's why orbital speed near the Earth's surface is 8,000 meters per second, otherwise known as 8 kilometers per second. And why do I say near the surface of the Earth? Because the farther away you get, the less gravity there is, therefore the slower your orbital speed. Near the Earth, it takes 8,000 meters per second. Farther out, where your acceleration due to gravity is different, and you're not going to fall 5 meters in 1 second, you might fall 4 meters in 1 second. Okay, that's going to widen the circle and decrease your orbital speed. All right, next. Number 15. Since the moon is gravitationally attracted to the Earth, why doesn't it simply crash into the Earth? We've got the Earth, we've got the moon. If the moon is attracted to the Earth by gravity, why doesn't the moon just go boom and destroy the Earth? Well, because the moon also has a whole bunch of, do you remember the word from chapter 8, the T word? What kind of velocity? T. Yes, tangential velocity. The moon is traveling tangentially. So as the moon falls, it's also moving horizontally, we'll call it, and therefore as it falls, it keeps missing the Earth, and it is in orbit just like the space station or anything else we have discussed. So what keeps it from falling to the Earth? It's tangential velocity. its horizontal component of the velocity. There was something else that occurred to me there. Oh, the speed of the moon. Someplace, I think I tried to reference this in the last video, and then after the video I did not look it up. But I believe I remember. Oh, I found it. I wrote it in here on page 193. That the moon's orbital speed is about 2,300 miles per hour. The moon's orbital speed, 2,300. The space station's orbital speed is about 17,500. Why the huge difference? Because once again, the farther away you are from the object, the lower your orbital speed. Going on, number 16. When the space shuttle coasts in a circular orbit at constant speed about the Earth, is it accelerating? You know about this. This goes back to a long time ago, back in like September. Remember the student killer. As the student killer goes in circles, is it accelerating? Yes, because acceleration is any change in, yes, I heard that word, velocity. That means acceleration is any change in speed or direction. And a circling object obviously is changing direction constantly. It is constantly accelerating. And no wonder, because as this orbiting object is going in a circle, in the case here it was the space station, here I'll use the moon. If the moon is going around in a circular orbit, it is always perpendicular to the force of gravity. So gravity is doing no work on it. Therefore, its speed is not changing. And I've already forgotten what the question was. Is it accelerating? Yes, because there is only one force acting on it. Therefore, it must be an unbalanced force. The only force acting on it is a force of gravity. And if you've got just one force, F equals ma, says that mass will accelerate if there's a force on it. It has to be accelerating. Oh, so what you're saying is it's going faster and faster and faster? No, don't forget your definition of acceleration. No, it's not going faster. It's just constantly changing direction. Number 17. Which planets have a greater period than one Earth year? Those closer to the sun or those farther from the sun? All right, suppose this is the sun, and this is a planet, and this is another planet. The planets farther away from the sun have a, yep, that's right, a slower orbital speed. Therefore, it takes them longer to get around the sun. Therefore, objects farther away from the sun than the Earth will have a longer orbital period, a very long year. What's the definition of a year? How long it takes that planet to get all the way around the sun. It takes us 365 and 1/4 days. It takes Pluto, I've forgotten how many years to get around the sun. A lot longer, how many Earth years? A lot longer than it takes Earth to get around the sun. The farther away it is, the slower its orbital speed. So that means Mercury and Venus have very short years. They get around the sun much more quickly than we do because their orbital speed is higher. Higher orbital speed for Mercury and Venus because they're closer to the sun. Moving on to number 18, goes right back to Galileo. Does the speed of a falling object depend on its mass? No. Ignoring air friction, all masses will accelerate together at the same speed. Does the speed of a satellite in orbit depend on its mass? Well, no. Because what is a satellite? It's nothing but a falling object that just happens to have a bunch of tangential speed also. So as it falls, it keeps missing the planet. So it's a good thing. I mean, otherwise we'd have a rough time with space travel. On the space station, you've got this huge, extremely massive space station, and inside you have these measly, puny little people. If they had different orbital speeds, what would happen? They'd be pinned to one side of the space station. No, the folks inside, with their small mass, have the same orbital speed as the space station with its huge mass, and they simply all orbit together, meaning that the occupants of the space station are therefore weightless. They have no support force. They're not being pressed against some side of the spacecraft. They are floating right along with it. If you take away the space station, they would still keep on floating, although they'd be rather unhappy, but they would still be floating at the same speed even without the space station. It's all dependent upon their distance from the Earth. Number 21. This one should be pretty simple. A satellite can orbit at 5 kilometers above the moon, but not at 5 kilometers above the Earth. Why can't you have an orbit 5 kilometers above the Earth? Aha, because there's too much air at 5 kilometers up. 5 kilometers up, you're going to be running into so much air, enough friction, it's going to cause you to slow down and crash right in. On the moon, however, there's no air worth mentioning, and so as long as that object is up high enough to clear the highest moon mountain, you can have an orbit, which is kind of a cool thought. You could climb to the top of the highest mountain on the moon, and if you had a way of firing an object horizontally at the moon's, the orbital velocity for the moon, which I don't know what that is, you could put that thing in orbit around the moon and wait a while. How long? I don't know. And you'd see coming back the moon, oh, there it is. And there it is. You could have an object in orbit just above the top of the highest mountain, which would be kind of a cool concept. But not on Earth. Too much air. Number 24. Why are satellites normally sent into orbit by firing them in an easterly direction, the direction in which the Earth spins? We've discussed this at length in class. Because the Earth is already turning, especially as you get closer to the equator, such as Florida. I've got a paper here someplace that tells me the orbital speeds of various, not the orbital speeds, the tangential speeds of the Earth at various locations. I just don't know where it is, but someplace here. Oh well. I think in Florida, the tangential speed of Florida is about 900 something miles an hour. At the equator, it's about 1,000. Let's suppose you're launching at the equator. The Earth is already turning at about 1,000 miles an hour toward the east. If you launch toward the west to go in orbit, you've got to make up for the 1,000 that you already have in the wrong direction. But if you launch toward the east, it's like the Earth gives you a boost. You've already got a 1,000 mile an hour advantage given to you by the Earth itself. Cool. That means you don't have to pick up as much speed to get yourself in orbit. Okay, and was that the last one? I think that was the last one. Any questions? Okay, I don't hear anything. So that means everybody's really straight on everything. I know I went through these kind of fast. If you have any burning questions, something you really don't understand, go ahead and email me, and I will try to get answers to you as quickly as I can. Let's see. Yeah, there's no assignment due on Wednesday due to my problems with producing videos on time. The part 2 of the assignment is due on Thursday. My plan currently is for the test to be on Friday. Oh, about the test. Hey, ask your parents to come in, please. Hey, Mom, Dad, could you come in here, please? Yeah, just for a minute. I know it's about 5 o'clock. You're making dinner, but please, if you both could just come in here for a minute. Thank you. Yeah, just have a seat on the couch. Thanks. This just take a moment. I want to make sure you understand how the test is going to work. On Friday morning, I will email the test to moms and dads only. Mom or dad will then take that test, print it out, and hand it to you, the student. You will then take the test, being proctored by mom and or dad. I expect them to be in the same room with you. No cell phones, please, mom, dad, make sure they don't have a cell phone. No Apple Watches, no laptop computers, nothing like that. Calculators are okay. I don't think they'll need one, but calculators are okay. Sometimes just having it makes them feel better. But please proctor the test. When they're done with it, sign it so I know that you were there. Parents sign the test, and then scan it or take pictures of it and email it back to me. I will be getting that test to you early in the morning. By early, I mean 9-ish. And then I will expect it to be returned by 3 o'clock in the afternoon. So you have from about 9 until 3 to get the test taken and back to me. That will occur on Friday. Okay, Mom, Dad, thank you. I'm done with you. You can leave. Anything else I need to say that's important? You know what part 2 of the assignment is, but it's not due till Thursday. And I think that's all I can think of for now. Of course, as usual, posted on RenWeb, I have a list of like 8 or so, if I don't, I will, 8 or so test preparation tips. Please pay attention to those. I know some of you have never looked at RenWeb for the homework assignments and the test taking tips, but I think they're good ones. Please take note of that. And above all, remember, read the book. It's far more clear in the book than I can make it. And if you think that I've been going too fast and babbling too much, read the book and things become clear to you. Check out Khan Academy. Put in something like orbital motion in Khan Academy. Put in Monkey Gun. I bet you he has something to say about Monkey Gun. But try Khan Academy. It's spelled K-H-A-N, not the other way around. K-H-A-N. Can I spell Academy? Academy.com. It's really good stuff on all kinds of subjects, not just math and physics. Okay, that's it. I'll stop boring you, and I will be communicating with you later. Farewell.